All right, so 3 cubed is 27, 4 cubed, 5 cubed, 6 cubed, 7, 343, 8, 512. Okay, beyond that, I don't think I need to know necessarily. Okay, so the pattern is when you have an a cubed plus a b cubed, it factors a plus b. And then this one is a squared, ab, and b squared. But this is what someone taught me to remember the signs. SOAP, okay? Whatever this sign is right here in the original problem, you keep it the same here, okay? This was a plus, this is a plus. O would be opposite, so it changes to minus. And AP is, this is always positive at the back. Okay, so if we had a cubed minus b cubed, it would factor a minus b, keep that sign. Then you change it, so a squared plus ab. And then the last one is always positive, so it's plus b squared. Okay? I don't know if that helps a little bit. Now, I want to do a couple, let's see, really messy ones. 343 b cubed minus 64. Okay. So what is the cubed root of 343? 7. What is the cubed root of b cubed? Okay. Cubed root of 64 is 4. And then I keep the sign, so this is a minus. Once I've written that first parenthesis, I don't look at this again. To get the second parenthesis, I use this one and I square it. Be careful, it's not 7b squared. 7b times 7b is 49b squared, right? Then the last one at the back is this one squared, so that's going to be 16. In the middle, it's a 7b times 4, which is going to be a 28b. And then remember this. So this one was minus, so that stays the same. This one up here was minus, sorry. So that stays the same here. Then it switches, and then this one is always positive. Better? Okay, you remember this from last year now? Do I need to do one more? Okay, so you have 8 questions in front of you. They're multiple choice. It's called a people puzzle. I think these are kind of fun because if you do the puzzle right, it answers some questions about a person. This one today is a human rights activist named John Prendergast. I said it wrong. Okay, so I'm going to pause the video for a second and let you work on this. Talk to somebody, see if you're getting the same answers. It's really not the same multiple choice as it is when you have to do it by hand, but it's good practice, okay? So the puzzle was pretty easy, but if we had 125a cubed, oh, what if I throw a b cubed in there? Minus 8d cubed. Could anybody try that one? What is the cubed root of that mess? That's going to go in the first parenthesis. This is an example. Good job. Okay. And the second parenthesis? 25. Good job. Good job. Good job. Good job. ABD. Boy, I made that complicated. Okay. Because you're doing this times this, right? But the sign changed. Now you're squaring 2D. 2d times 2d would be 4d squared. Okay, was that messy enough? You think you got the pattern though? All right, the next thing we're going to talk about today is finishing up complex numbers and answering questions on worksheet 2. So can you take out worksheet? I think it's 3 that we need to finish going over. We didn't talk about powers of I yet, and we didn't really concentrate on using conjugates to rationalize the denominator. Worksheet 2, I just want to know, you're supposed to have done worksheet 2, the evens, right? But I want to know if you have questions or if we need to do odds for practice, okay? We'll get to that in a second. First of all, let's finish complex numbers. This is what I want to talk about real quick, just as a review. If it said x to the 6th, this is a warm-up question here, times x to the 4th, that would be what, guys? X to the 10th. Everybody okay with those rules? If it said x to the 3rd to the 4th, it would be what? Okay, everybody all right? Because this would mean x to the 3rd times itself 4 times, which would be 3, 6, 9, 12 of them, right? Everybody good? All right, so we're going to use this idea and the definition of I to solve some problems today. So we're going to talk about this, powers of I, and then rationalizing with using a conjugate, okay? We already did some of this. I'm going to skip this warm-up for now. All right, so the definition of I was square root of -1. So if we had something like the square root of -25, we'd just get 5i because it would be the square root of -1 times the square root of 25. Everybody okay with that part? Okay. Then we decided that if you squared these, it isn't working. I put in a tech request. I sent stuff to printer B in the copy room B. No, I can get a 3rd hour because I need to make some more copies. I just sent a single one down because I wasn't sure it was working. All right, so if we square this side, we're going to square this side. And what's going to happen when we square a square root of -1? The square root of -1 squared will be what? Yes, the squared and the square root will cancel out. We'll just have -1. Now, if we do this again, we're going to multiply by an I on both sides, so we'd get -1i. If we do that to the 4th, we're multiplying by another -1, square root of -1. So what would that give us? I squared times -1. And I squared is, told me up here it was -1, so we'd have -1 times -1, which is 1. All right, powers of I, those are the only 4 answers you can get. Okay, when you have any power of I, you could just end up with an I, you could end up with a +1, you could end up with a -I, or a -1. I did that in the wrong order if you're going to do them in order, but those are the only 4 possible answers, okay? Now, the book talks about when you have a power like this, crazy business, which your calculator won't do and which you can't use a graphing calculator for anyway, on the quiz, it talks about like dividing by 4 and seeing what your remainder is and all this kind of crazy business, okay? I'm not smart enough for that. What I do is I think of how, I only remember these 2 because I can't remember all this other stuff. I remember I and I squared, okay? And then I would do, for this question, I'd say, well, this is an odd, and I don't like odd numbers, so I'm going to take out an I. How many I's will be left if I pull one out of 637? Okay. Now, I have this I left out here, and I know what I squared is. Well, how many I squareds is this? If I divide this by 2, I'd get what? 318? Okay. So now I say I squared is really what? -1. Okay. So now I have -1 to the 318th power, which you could do on your scientific calculator. But what's -1 to an even power going to be? +1. And times this I out here. So I'm just going to get I. Okay. So we're going to practice this with a couple examples. They have I to the 53rd here. All right, that is an odd. So I'm going to poke an I out. Ha ha ha. Going to put one I out front, and that'll leave how many I's? 52, right? Okay. 52 is an even number if I divide it by 2, so I have an I squared. How many I squareds would I have? Okay. So I squared is really -1, yes, to the 26th power, which is +1, times that I we poked out just makes this one I. Okay. The book would say we started with an I to the 53. Well, every 4 of those cancels out and goes away. If you divide 53 by 4, okay, you get 12 is 48. What's the remainder? Well, you can do 13. Thank you. Is 52. So you have 1 is the remainder. So that's what's left is one I. Okay. My issue is if the remainder is 3, then I have to figure out what I to the 3rd is. And I only memorized I and I squared. So you can do it either way. All right. What does that say? Oh, that was a new example, wasn't it? Okay. Like, why is that there? Okay, this is an example I was going to do. But I'm going to first do this I to the 86th over here. I to the 86th is even, right? So I could just say it's an I squared how many times? It was an 86. I want to divide it by 2. Everybody good that 2 times 43 would be 86? And what is I squared? Okay, -1 to the 43rd power. Well, a negative number, an odd number of times is going to be negative, and 1 times anything is 1, so we get -1. All right, so my question is, let's try 279. What do you want to do to 279? You want to divide it by 4? You want to try their method? Okay, if you take 279 and divide it by 4, let's see, you'd have 6 is 24, 39. Did I do that right? You'd have 36, you'd have remainder 3. Yes? Okay. So 66 of them, it went in 66 times, which is 1 to the 66. So that's gone because 1 to any power is 1. So there's 3 I's left over is what this means. It simplifies down to an I cubed. Do you know what an I cubed is? Yeah, because it's an I squared times another I, right? Which is -1 I. All right, how many of you hate powers of I right now? All right, You may try a couple more. So somebody make up a high number. I'm going to go with that. I heard that or something. I don't know. Anyway, it's even, right? So my method would be to just to divide it by 2. Is it 292? Okay. And what's I squared? So a negative 1 to the 292nd power is positive 1. Okay. The trickier ones are the odd ones. If this is 301, I'm going to put 1 out there and leave 300, right? And that becomes what? I squared 150 times, and there's an I out here still. This is negative 1 to the 150, which is 1. So all I have left is 1 times I, which is I. One more? Yes. Let's do 303 just to be easy. Because I would take 1 out and then I'd have 302, which is what? I squared 151 times, which is negative 1 to the 151. And what's a negative 1 to an odd power? So I'm going to have a negative 1 times that I out there, which is negative I. Better? Keaton, you see that now? When you divide by the 2, if you get an even or an odd number, yes, yes, yes. Okay. Just like if I had had here I to the 202, it would have been I squared to the 101, which would have been negative 1 to the 101, which would have been negative 1 because it's odd power. Those are all 4 right there. Negative 1, positive I, or negative I. Okay? All right. I think I've kind of killed that for today. We can do some more examples tomorrow or something if you need to. All right. We did this question on Friday. Does anybody remember we talked a little bit about conjugates? When you multiplied 4 plus 5i times 4 minus 5i, remember you didn't end up with a I in the answer at all. Okay? So conjugates, it says up here, A plus BI and A minus BI are called complex conjugates. Just be real careful. The only thing that changes is the sign in the middle, right? On the B or on the I part. All right. So this example right here says 5 minus 3i is being divided by 1 minus 2i. I don't know why it's written like divide, but it's not on the quiz. It's written like this. What's wrong with this? Why isn't this a perfectly fine answer? Can't have an I in the denominator because it's really a radical and blah, 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 blah. Okay, so we have to get rid of the denominator's wrong. The numerator's not wrong. But in order to get rid of the denominator with an I, we have to do the conjugate. And whatever we do down here, we're going to multiply by 1 plus 2i. We have to multiply to the top because we can't change the kind of number it is. It's multiplying by a form of 1, right? All right. Now we have to do a lot of foiling. If you're really good at foiling here, 5 times, I'm doing the top, okay? 5 times 1 is 5. 5 times 2i is plus 10i. Negative 3i times 1 is negative 3i. And negative 3i times positive 2i, negative 6i squared. Okay. On the denominator, 1 times 1 is 1. 1 times positive 2i. Then I have a negative 2i times 1 and a negative 2i times 2i, which would be negative 4i squared. Now, what happens next? Yeah, the I squared, negative 6i squared will become what? Negative 6 times negative 1, or positive 6. And negative 4i squared is negative 4 times negative 1, or positive 4. All right, so what happens when I simplify the top? 11 plus 7i sounds right. And in the denominator, those disappear, right? 2i minus 2i. And I get 1 plus 4 is 5. Where did I lose you, Maura? Were you lost? I saw a confused look. Okay. This is okay with me. You're actually supposed to leave all your answers in A plus BI form, which would say 11/5 plus 7/5 I, where this is the real part and this is the imaginary part. But I'm okay with either one. All right. All right, so what about 4b right here? The conjugate would actually be negative 7i, right? And we can do that. I'm going to show you a trick, though. If we do that and distribute it to the top, what do we get? I squared, okay. And in the denominator, we get 7i times negative 7i is I squared. Okay. Now, I squared is negative 1 times negative 35 is going to make this a positive 35, right? I squared is negative 1 times negative 49 is going to make that a positive 49. What do you notice? They all are divisible by 7. So if I separated this as a fraction, let's see, the real part is 35 over 49, right? The part that still has an I is a negative 14 over 49. So those would reduce by 7 to 5/7 minus 2/7 I. How did I do? Okay. The trick is you really only wanted to get rid of the I in the denominator, right? So you could have actually, back here at the original question, because the bottom was pure imaginary, it didn't have a real part to it, you could have just multiplied the top and bottom by I. You'd get 2i plus 5i squared, which would be a negative 5, all over 7i squared, which would be a negative 7. And that's equivalent to this, because you'd have a negative over negative is positive 5/7. So if it just has something with an I in the denominator, you can just multiply top and bottom by I, otherwise it's going to reduce. But if it has a real part to the complex number, then you have to do the whole conjugate. You want to do another example of that, or are you okay? Okay. Like one more with just an I in the denominator, or with a, okay, like 3 minus I over 2 plus 5i. Okay, what's the conjugate going to be? Okay. Who's good? Anybody want to FOIL the top together for me? 6. Plus, be careful, plus 5i squared, right? All right. The denominator, okay. Now, some of you start scribbling things out and it gets to be a mess, right? And you make a mistake. So if you wanted to rewrite the top, you have a 6. You could combine those two and get a minus 17i. What is positive 5i squared going to become? A negative 5. What happens down here? We get a 4 plus 25. All right, then I think on the top I have a 1 and a minus 17, right? And on the bottom I have 29. So I could separate it, or I could leave it as 1 minus 17i all over 29. I don't care. Better? All right. So one more thing. Everybody good? Oh, this one, it just says, here's an application. They actually use eyes in electrical engineering and work with electricity, the theoretical part of it anyway. They use the letter J instead of I, just because it's easier to not get confused with the look of it, I guess. But it says if you want the voltage, you take the current times the impedance. So for this question, all they want you to do is to find, well, I guess they call it E. I'm already messing you up. You would do the current times the impedance, and they use J. It's just the same definition, though. It's just I. So if I FOILed that together, okay, if it's really an I, this one back here is going to become what? Yeah, plus 15. So then we'd have 22 plus 16J, is that right? And it is voltage. It says they want that in volts. There's not an application question on the quiz. And I think the one on the homework, doesn't it just ask you to add? The one on the homework that's a word problem just asks you to add. You don't have to multiply them. I thought I had something else in here though. Oh, this question. Here we go. This looks horrible. On your homework, this is in your notes. It says, given two complex numbers, the real part must equal the real part and the imaginary part must equal the imaginary part. So if you had 2a plus 5i equals 6 plus bi, what are a and b have to be? This is scary because there's 3 variables in there, right? But what's real on this side is a 6, and what's real on this side that doesn't have an I is a 2a. So if 2a has to equal 6, then a has to be 3. That's it. And the imaginary part is 5i, and the imaginary part on this side is bi. So if 5i equals bi, then 5 has to equal b. So here's another example. This is in your notes. It's kind of hard to read, but I think it says 12 plus 7iy equals 3x plus 21i. Okay. So what's the real part on the left that doesn't have an I? 12. What's the real part on the right that doesn't have an I? 3x. So if 12 has to equal 3x, then x has to be 4. 7iy is imaginary. And over here it has to equal 21i. Well, you could knock the I out of each, right? And you'd have 7y equals 21, so y would have to be 3. Super easy. It's just kind of confusing when you look at it because it has so many variables. Does anybody know what number on the homework that is? It's on the bookwork. What one is it? 47 is like this? This is like number 47 on the bookwork, okay? Let the real part equal to the real part, the imaginary part equal to the imaginary part. Everybody okay? All right, before I start anything else new, do you have questions? I'm going to pause the video.